All right, today we're diving into something that is literally everywhere, in everything, all the time. I'm talking about the force that moves mountains, powers our entire civilization, and yeah, it's also at the very heart of our planet's biggest challenges. So, let's get right into it.
I mean, really think about it for a second. The journey your breakfast took to get to your plate, the screen you're watching this on right now, even your brain's ability to process what I'm saying. What's the one thing, the single universal currency that makes every single bit of that possible?
Yep, you guessed it, energy. It's like the invisible engine of existence. And today we're going to break down what it really is, where we get it from, and where we're all headed next.
Okay, so let's just start with the basics. It's a word we throw around all the time, right? But what does it actually mean in a scientific sense?
So this is basically one of the most fundamental rules in all of physics. It's called the first law of thermodynamics. And it just says you can't make energy and you can't destroy it. You can only change its outfit. The chemical energy locked up in a piece of wood, it transforms into heat and light when you set it on fire. The potential energy of water held back by a dam, that gets transformed into the electrical energy that powers your home. It's all just one big cosmic costume change.
And this, right here, is the absolute key. Our entire human story, everything we've ever built, is all based on us getting better and better at this one magic trick: transforming energy. It doesn't matter if it's a simple campfire or a super complex nuclear reactor. The game is exactly the same. Convert energy from one form into another form that's actually useful for us.
And man, just look at how our mastery of this has grown over time. For literally hundreds of thousands of years, our energy footprint was tiny. Then farming came along, and it doubled. But the real game changer, the explosion, happened during the Industrial Revolution. The second we figured out how to tap into the super concentrated energy packed into fossil fuels, our consumption just went vertical. I mean, that last point is just mind-boggling. 115 times more energy use per person. That's the sheer scale of the modern world we've built.
Which of course brings us to right now, to the modern era. An era that is really defined by one overwhelming fact: our deep, deep reliance, you could even say addiction, to fossil fuels.
Yeah, this chart here paints a really clear picture of our global energy diet. Just look at those big chunks, coal and natural gas. Together they make up nearly 60% of all the electricity generated on the entire planet. And if you look over at that little slice for wind and solar, well, you can see it's still a pretty small piece of the pie.
And this global picture gets even sharper when you zoom in on a specific country. Take a rapidly growing economy like India. Their number one priority is getting power to a huge, growing population. And as you can see, coal is the absolute bedrock of their system. And look, this isn't unique to India. It's a pattern you see in a lot of developing nations all over the world.
So we all know the big, obvious problem, right? Climate change. But there's another issue, one that doesn't get talked about as much, and it's just as shocking. Our current system, it isn't just dirty, it's also incredibly, unbelievably wasteful.
Just let that sink in. 2/3. To put that into perspective, imagine for every $3 you spend on gas for your car or for electricity from a coal plant, 2 of those dollars are literally paying for energy that just, poof, disappears as waste heat. It does absolutely nothing useful. That is an insane amount of inefficiency baked right into the system that we all rely on every single day.
And this is why the search for clean, efficient power isn't just some nice-to-have idea. It is an absolute necessity. So, okay, let's start looking at the alternatives.
I mean, think about the sun. It bathes our planet in more energy every single hour than all of humanity uses in an entire year. The raw power is there. The challenge has always been, how do we catch it? How do we actually turn pure sunlight into the electricity that powers our lives?
Well, it all comes down to something called the photovoltaic effect. And you can kind of think of it like a game of subatomic pool. A little particle of light called a photon shoots in and bam! It hits an electron, knocking it loose. This sets off a chain reaction, creating a flow. And that flow of electrons, that's what we call electricity. It's this beautiful, elegant, direct conversion of light into power.
And the whole thing is governed by this fundamental principle of physics, this equation here. You don't need to be a physicist, but it basically shows that the energy of light is baked right into its properties. This is the science that makes every single solar panel on Earth possible. It's all about harnessing the energy that's packed into one single particle of light.
But, you know, solar is just one tool in the box. Our clean energy toolkit is actually pretty diverse. We've got harnessing the raw kinetic power of the wind with massive turbines, using the steady flow of water with hydropower. We can even tap into the Earth's own natural heat with geothermal. And, of course, unlocking the immense energy stored inside the atom itself with nuclear power. Every single one of these has a role to play in building a cleaner grid.
So, with all these amazing ways to generate clean electricity, what's the holdup? Why isn't everything renewable already? Well, it turns out that making the power is only half the story. The other half, the much, much harder half, is figuring out what to do when the sun isn't shining and the wind isn't blowing.
This is the big challenge for renewables. It's called intermittency. See, our electric grid demands a perfectly stable 24/7 supply of power. But the natural world, it doesn't really care about our schedule. So what's the solution? Well, we need a way to store absolutely massive amounts of energy for when we need it most.
And when I say massive, I am not kidding. Projections are showing that by 2040, the world is going to need 140 terawatt hours of grid storage. That number it's almost too big to even wrap your head around, and it represents one of the single biggest engineering challenges of our time.
Right now, we mostly rely on lithium-ion batteries, the same kind that are in your phone and laptop. They're great, but they've got their limits, right? They rely on scarce materials like lithium, and they only last for so long. But now, look at what's on the horizon. We're talking about technologies like these air batteries. They use stuff that's super abundant, literally salt, air, and water, to create storage systems that can last for decades. And they can hold energy not just for a few hours, but for weeks or even months at a time.
So here's the basic idea. When you have extra power from your solar panels or wind turbines, you use that electricity to pump compressed air into these enormous, geologically stable salt caverns deep underground. It's like inflating a giant rocky balloon. Then, when you need the power back, you just open a valve, release the air, and it spins a turbine on its way out, generating electricity. It's a beautifully simple, powerful, and scalable idea for the grid of the future.
You know, from mastering fire to figuring out how to store the wind in a cave, our relationship with energy is constantly evolving. The transition to a clean energy future, it's not a question of if anymore, it's already happening. The technology is getting better every day, the challenges are crystal clear, and the solutions are actually within our grasp. So the real final question isn't about the technology, it's about us. What part are we all going to play in building it?